Welcome to The Explainer. Today we are going deep. We're not just scratching the surface of some new tech. We're going to take a really close look at a fundamental shift happening at the very core of our modern world. I mean, just think about it for a second. The internet, your phone, all the cloud services you depend on every single moment of the day, every bit of it is built on this huge, intricate, and honestly, increasingly strained foundation of telecom networks. For decades, managing all this complexity has been a human job, often a painstakingly manual process. It's really a testament to the brilliance of network engineers, but it's also become a major bottleneck to innovation. And right now, we are standing at a profound turning point. Two incredibly powerful tech currents are converging. The first is a whole new vision for network automation, an open-source project called Nephio, which is bringing the rulebook of the cloud to the world of telecom. And the second? Well, it's the startling power of generative AI, with its ability to understand, to create, and to reason. The synergy between these two isn't just about making networks more efficient, it's promising to make them fundamentally smarter. In this explainer, we will carefully pull apart this relationship, from the basic principles all the way to real-world applications, from the incredible potential to the critical guardrails we absolutely have to build. So get ready to go in depth as we map out the architecture of our digital future. This one sentence right here from the Linux Foundation white paper that's our guide today is the perfect anchor for our entire conversation. It's packed with so much meaning, and to really get why solutions like Nephio and AI are so important, we have to spend a moment on the monumental problem it describes. So let's break down these three driving forces. First up, 5G. It's easy to think of it as just faster 4G, but that completely misses the point. The whole architecture of 5G is a quantum leap. It's designed for a massive density of devices, not just our phones, but billions of sensors in a smart city or a factory. It's also built for ultra-low latency, that near-instant response time you need for things like remote robotic surgery or cars talking to each other to prevent accidents. That combination of scale and performance puts a kind of strain on the network we've just never seen before. Second, edge computing. This completely flips a decades-long trend of centralizing everything. Instead of processing data in a few giant faraway data centers, we're pushing compute power closer to where the data is actually being created, out at the edge. This could be a server rack in a retail store, a compute node at the base of a cell tower, or a local server in a factory. This creates this massively distributed network with thousands, maybe millions of endpoints that all need to be configured, updated, and secured together. And third, you have cloud-native technologies. This is the how of it all. It's about building network functions not as big monolithic black boxes, but as flexible apps using containers and microservices, all orchestrated by platforms like Kubernetes. This brings incredible agility, but it also introduces a dynamic complexity that the old management tools were just never built to handle. So what you have is this perfect storm: the massive scale of 5G, the massive distribution of the edge, and the dynamic complexity of the cloud. This is the new reality, and it's a reality where the old ways of doing things, they just fall apart. All right, so to navigate this complex landscape, we've laid out our explainer as a journey, a kind of roadmap to guide us from the core problems to the future vision. We'll kick things off by digging deeper into a new networking reality, looking at exactly how traditional automation is cracking under the pressure. From there, we'll unpack Project Nephio, the first piece of the puzzle, getting to know its core ideas and key parts. Then we'll get into why Nephio and Gen AI are the perfect match, seeing how generative power can turbocharge this new framework. Once that's clear, we'll get practical by putting Gen AI to work, looking at concrete examples that solve real problems. Next, we'll zoom out to check out the ecosystem and critical guardrails, seeing how Nephio plays with other tools and talking about the absolute need for responsible AI. And finally, we'll pull it all together by orchestrating our connected future, looking at what's on the horizon. Let's get started. So, let's start at square one, the problem. To really appreciate the elegance of the solution that Nephio and AI bring to the table, we first have to have a deep respect for the insane pressures that network operators are facing today. The methods that have worked for decades aren't just showing their age, they're actively failing. They're becoming an anchor, holding back progress in this new reality we've just sketched out. Let's really dig into the specific reasons why this is happening.
This slide really lays out the fault lines in the old way of doing things. Let's walk through them, because each one is a huge barrier. First up, the imperative approach for configuration. This is the classic method. An engineer writes a script, a very precise list of commands. Log into this router, enter this mode, apply this rule, set this protocol, save. You're telling the system how to do its job, step by step. And that works fine for one device, but in a network with thousands of devices, these scripts become these fragile, complex monsters. Change one little thing and you might break something totally unrelated. Then there's the difficulty coordinating multi-vendor, multi-cloud environments. I mean, no major company uses just one vendor. They have routers from one, switches from another, firewalls from a third. And they run services on their own private clouds and on public clouds like Google, Azure, and AWS. Each vendor, each cloud has its own unique way of being managed. Trying to roll out one service across that patchwork quilt is an absolute nightmare of custom integration. And that leads directly to slow response times. If a business wants a new service, it could kick off a months-long process of filing tickets for the network team, the security team, the cloud team, all of them manually plugging away at their piece of the puzzle. In today's market, that's just dead on arrival. Then you have the sheer complexity of managing interconnected workloads at scale, which goes hand in hand with heavy vendor dependency. For years, vendors wanted to sell you a black box that only worked with their gear, locking you into their ecosystem. And finally, all of this adds up to slow learning curves and skill gaps. The amount of specialized knowledge needed to run this mess is enormous, making it incredibly hard to find and keep the people you need.
So what happens when you pile all these problems on top of each other? Well, it's not just a technical headache. It's a fundamental business crisis. You end up with a system that's slow when the market demands speed, brittle when you need it to be resilient, and overwhelmingly complex when you need to be agile. This operational drag is actively choking the very innovation that things like 5G and Edge are supposed to unleash. Companies have all this potential to create amazing new things, immersive AR, fully autonomous supply chains, you name it. But that potential is stuck behind this wall of legacy complexity. You just can't build the dynamic, on-demand services of tomorrow with the static manual operational models of yesterday. And it's precisely this gap, this chasm between what's possible and what's practical, that Project Nephio was born to fix. Okay, so now let's turn our attention to the first part of the solution. Let's focus on Project Nephio itself. You know, Nephio didn't just appear out of thin air. It was created by industry leaders who were living these problems every single day. And it represents a fundamental rethinking of network automation. The goal isn't just to slap another bandage on the old broken systems. The goal is to build an entirely new foundation, one that takes the principles that have been battle-tested and proven in the cloud-native world and applies them directly to the unique, high-stakes game of telecommunications. This timeline really shows that Nephio is way more than just a concept on a whiteboard. It's a living, breathing project that's picking up steam at a remarkable pace. When it emerged back in 2022, with heavy hitters like the Linux Foundation and Google Cloud behind it, that was a huge signal that the industry was ready for something new. And its progress has been fast. Release 2 in early 2024 was a landmark. It delivered on that crucial promise of better multi-vendor and multi-cloud support, tackling one of the biggest pain points we talked about head-on. Just a few months later, Release 3 added more functionality and hardened the security, things that are absolutely non-negotiable for production telecom networks. And the community growth of 40% yearly jump in contributors shows that people aren't just watching. They're rolling up their sleeves and getting involved. And maybe the most important part? This isn't just theory. Major telecom operators are already using Nephio to deploy and manage real-world 5G networks. This isn't some future promise. It's happening right now.
To really get what makes Nephio so different, you have to wrap your head around this one massive philosophical shift, moving from imperative to declarative automation. Let's use the taxi analogy. The old imperative way is like giving a driver turn-by-turn directions. Drive 2 blocks, turn left, go 3 more blocks, turn right. The instructions are super precise, but the second there's a road closure, your whole plan is useless. The declarative way is totally different. You just give the driver your destination, the desired final state, and you trust them to use their knowledge, their GPS, and real-time traffic to figure out the best way to get there. If a road is closed, they just reroute, no big deal. You declared the what, and you let the system handle the how. In networking, this means instead of writing a 1,000-line script to set up a new network function, you create a simple file that says, I want a 5G user plane function at this site with this much capacity connected to these other services. It then becomes Nephio's job to figure out how to make that happen, and, this is key, to constantly watch the system and make sure it stays that way.
So how does Nephio actually pull off this declarative model? Well, it's built on two foundational pillars. The first was the absolutely brilliant decision to use Kubernetes as a uniform automation control plane. Look, Kubernetes has already won the war for container orchestration in the cloud. It's the standard, it's robust, it's extensible. So instead of reinventing the wheel, the Nephio founders decided to just leverage this powerful platform and extend it to understand networking concepts. This gives you a single, consistent way to manage everything, from the cloud infrastructure itself to the network functions from all the different vendors. That word uniform is everything. It smooths over that multi-vendor, multi-cloud chaos. The second pillar is the declarative automation framework that's built on top of Kubernetes. This is where the idea of configuration as data really comes alive. Instead of configs being buried in scripts or locked away in some vendor database, the desired state of the entire network is defined in structured data files. These files can be stored in a Git repository, versioned, reviewed, and audited, just like source code. This brings all the discipline of modern software development to network operations.
Okay, let's pop the hood for a second and look at the actual engines that make this thing go. First, you've got KPT packages. Think of these like standardized reusable blueprints for your network services. A vendor could create a KPT package for their 5G core function, and it would contain all the Kubernetes configuration needed to deploy it. This reusability is a huge time saver. Second, there's Porch. If KPT packages are the blueprints, Porch is like the central library and management desk for those blueprints. It's an API server that lets different teams at a big company discover, customize, and approve different versions of these packages. It provides the governance you need to manage this stuff at scale. And finally, and this is maybe the most critical piece, you have config sync. This is the heart of the declarative model. It's a little agent that runs in your network with one tireless job: to constantly watch a Git repository, which is the single source of truth for how the network should look. The moment a new config is approved and merged into Git, config sync sees it, pulls it down, and applies it. It also never stops checking. It's constantly asking, does the real world match what's in Git? If some engineer makes a manual change on a router, config sync sees that drift and can automatically fix it, pulling the network back in line with the approved intent. It's this continuous loop that makes the system so resilient. Okay, so we've established Nephio is this powerful, declarative, GitOps-driven framework for automating the network. And on its own, it's a massive leap forward. But now we bring in the catalyst, the force multiplier, the thing that promises to elevate this whole system to a completely new level of intelligence and simplicity: generative AI. This fusion, this is where the future of network automation really gets exciting. Before we go any further, we've got to be really precise with our words here. AI gets thrown around as a buzzword all the time, but the differences are critical. Artificial intelligence, AI, is the big umbrella term. Anything that simulates human intelligence. In our world, a traditional AI might analyze network data to predict a potential hardware failure. Machine learning, ML, is a subset of that, where systems learn from data without being explicitly programmed. An ML model could analyze past traffic patterns to learn the best way to route data during rush hour, and it gets better over time. But the real game changer here is generative AI, Gen AI. Unlike its cousins that mostly analyze or predict things based on existing data, Gen AI is about creation. It generates brand new content: text, images, and in our case, the complex configuration code that defines a network. That's a profound difference. It moves the AI from being a passive analyst that gives insights to a human to being an active co-pilot that can create the very building blocks of automation itself. This concept, the closed-loop model, is really the ultimate goal of autonomous networking. It's a self-regulating, continuous cycle. Let's walk through it. First, the system has to observe. It's constantly collecting real-time data from all over the network: traffic, latency, errors, everything. Second, it has to analyze. This means it compares what it's observing in the real world to the intent, the desired state that's defined in Nephio's configuration data. So the intent might say latency for a premium service has to be under 10 milliseconds. The system observes it's at 18 milliseconds. Okay, we have a problem. Third, the system has to act. It needs to automatically do something to bring the network back into compliance. And this is where the synergy with Nephio and GitOps is just so beautiful. The AI's act step isn't to log into a router and type commands. Instead, the AI generates a new configuration file,
maybe one that adjusts a quality of service policy, and submits it as a proposed change to the Git repository. From there, Nephio's standard, trusted, auditable workflow takes over to safely test and roll out that change. The AI provides the brainpower, but Nephio provides the safe, reliable nervous system to carry out the decision. This table really shows what a huge evolution this is for the role of the human network engineer. And it's so important to see this isn't about replacing people, it's about augmenting them, supercharging their skills, and elevating their work. Let's compare these two worlds. In the old way, a highly skilled engineer had to manually write all this complex Kubernetes code just to teach the system about new network concepts. In the new way, Gen AI can just write that boiler code from a simple, high-level description. In the old way, an outage at 3 a.m. meant a human had to start digging through mountains of logs. In the new way, an AI does that initial analysis, correlates events, and suggests the likely cause and fix. And the biggest shift is this last one. In the old way, a business request for a new secure service would kick off weeks of people manually translating that into thousands of lines of code. In the new way, you can feed that same natural language request to a Gen AI, and it generates the initial validated configurations for Nephio. The human engineer is freed from being a low-level keyboard jockey and is elevated to the role of a strategic pilot who guides the AI, validates its work, and focuses on designing the next cool thing instead of just typing. All right, so we've covered the theory, we've covered the architecture, but how does this powerful combo of Nephio and Gen AI actually show up in the day-to-day grind of running a network? Let's move from the abstract to the practical and look at some specific high-impact use cases where this can solve some of the most time-consuming and frustrating problems in network operations today. Okay, get ready for this, because this chart, based on the source data, is honestly, it's kind of stunning. It points to this massive, often hidden, black hole of inefficiency in modern network and cloud ops. It suggests that operations teams can spend up to 80% of their time on two related tasks: template creation and hydration. Just let that sink in. 4 days out of every work week are spent on what is basically just really sophisticated paperwork. Template creation is designing the generic blueprint for a service. Hydration is the grueling, manual job of taking that generic template and then copy-pasting in all the site-specific details, IP addresses, server names, VLAN IDs, for hundreds or thousands of individual locations. This work isn't just boring, it's a huge source of human error. One little typo in one IP address during this process can cause an outage that takes senior engineers days to track down. This 80% figure is a massive anchor of pure toil, and it's the perfect target for Gen AI. So let's walk through how Gen AI and Nephio completely blow up that 80% problem. The workflow is just elegant. First, generate. An operator gives the system a simple natural language request, like generate a KPACT package for a new branch office. It needs redundant connections and has to follow our PCI-compliant security rules. The Gen AI, which has learned from the company's existing best practices, just generates the base template. Step 2, hydrate. This is where the magic happens. The operator provides a simple list of the 500 new offices that need this service. The system then takes over. It automatically queries the company's other systems. It gets IP addresses from the IP management system, server names from the inventory database, firewall rules from the security engine. It then populates 500 unique, validated, site-specific configuration packages. A task that used to take a team weeks of manual work is now done, without any errors, in minutes. And finally, step 3, reconcile. Once those 500 configs are approved and committed to Git, Nephio's normal reconciliation loop takes over to deploy and manage them, forever making sure the live network never drifts from what's in Git.
This quote from the white paper just paints such a vivid picture of the ultimate user experience, the Nephio AI assistant. This is all about changing the command line interface from a rigid tool that requires memorizing hundreds of commands into an intelligent conversational partner. For decades, using a powerful system meant having a huge learning curve. This vision just flips that on its head. Imagine an engineer just typing, "Nephio, I need to stand up a new 5G core for a proof of concept in our Dallas data center. Make it support 5,000 users and use the high availability profile." The AI assistant could then have a conversation. "Got it. For the high availability profile, do you want active-active redundancy across 2 zones? This just lowers the mental burden on the user and lets the experts focus on expressing what they want, not on fighting with YAML syntax.
So to make that vision a reality, the Gen AI system basically has to be bilingual. It needs 2 different faces to talk to the world. On one side, you have the human interface. This is that conversational partner we just talked about. It uses natural language processing, or NLP, to understand what people want, gives smart answers, and learns over time. Its main job is to make life easier for the human operator and keep them in the loop. But just as important is the other side, the machine-to-machine interface. This is how the AI talks to all the other automated systems. Here, the AI acts like a universal translator, sorting out all the different APIs from various network devices. It makes autonomous decisions based on real-time data to make that closed-loop automation happen. It can even generate fake network traffic to test a change before it goes live, or coordinate with other systems to fix a fault without waking anybody up. A truly smart network needs both of these faces, a simple, intuitive one for its human partners and a precise, autonomous one for its machine buddies. So, how do we actually build this bilingual AI? Well, it really comes down to 2 key technologies. First, at the core, you have LLMs, large language models. These are the powerful engines, you've heard of them, that have been trained on basically the entire public internet. They're what give the AI the ability to understand and generate human-like language and code. But a generic LLM by itself isn't good enough. It doesn't know anything about your specific network. It doesn't know your IP address plan or your security rules. If you ask it to generate a configuration, it might just make something up. That's what we call a hallucination. And this is where the second technique, RAG, or Retrieval-Augmented Generation, is an absolute game changer. RAG is how you ground the LLM in your company's reality. Before the LLM tries to answer, the RAG system first retrieves relevant, up-to-date information from your own private data sources, your Git repos, your internal wikis, your real-time performance data. It then gives this specific info to the LLM along with the user's question. It's like giving the AI an open book exam, where the book is your entire company's knowledge base. This simple but powerful technique massively reduces hallucinations and makes sure the AI's answers aren't just plausible, but are accurate, safe, and totally relevant to your unique network.
Now, a technology this powerful and this transformative doesn't exist in a bubble. It can't. So to really appreciate Nephio's role, we need to zoom our lens back out and understand how it fits into the bigger picture of open-source networking projects. And even more importantly, as we start to hand the keys for network configuration over to a generative AI, we have an absolute duty to talk about the guardrails, the security frameworks, the transparency, the compliance structures that are required to make sure this power is used responsibly and safely.
This point is so important for understanding how the modern open-source world works. The best way to think about it is not as a battlefield where one project has to win, but as a well-stocked toolbox, where every tool has a specific job it's really good at. Nephio's specific job, its sweet spot, is that declarative, GitOps-driven automation of cloud-native network functions. But to build a complete service from end to end, an operator is going to use a bunch of these tools together. For example, they might use Anucut and Silva to standardize and deploy the cloud infrastructure itself. Then they'd use Nephio to deploy and manage the network functions on top of that infrastructure. They might use a project like ONOP for higher-level service orchestration, especially if they still have older systems to deal with. And they might use Kamara to create simple APIs to expose the network's capabilities to outside developers. These projects aren't fighting each other. They're collaborators, each solving a different piece of a very big puzzle. This brings us to what is, without a doubt, the single most important question in this entire conversation. We are talking about giving an artificial intelligence the power to generate and deploy the configurations that run our critical communications infrastructure. The potential for innovation is incredible, but the potential for catastrophic failure, whether it's an accident or on purpose, is just as real if we don't handle this with extreme care. So how do we build systems that are not just powerful, but are also open enough that we can inspect them, transparent enough that we can understand them, trustworthy enough that we can rely on them, and secure enough that we can defend them? How do we avoid creating these opaque black boxes that run our critical infrastructure, but whose inner workings nobody really understands or controls? This is the central challenge we absolutely have to solve. We have to be really clear-eyed about the new security vulnerabilities this whole paradigm creates. Those RAG pipelines that make the AI so smart, they also create a new attack surface. By design, they access sensitive company data. If they're not secured properly, they could be a backdoor for data theft. An even scarier threat is data poisoning. Imagine an attacker subtly corrupting the data an AI model is trained on. They could, for instance, teach the model that a really insecure configuration is actually a best practice. The model would then, in good faith, recommend and generate this vulnerability, effectively creating hidden backdoors that get deployed automatically across the whole network. The National Institute of Standards and Technology, or NIST, is already classifying these AI-specific attacks. Defending against them needs a new, multi-layered strategy. It means we need secure supply chains for AI models, so we know where they came from. It requires clever prompt engineering to stop people from tricking the AI, and it'll almost certainly require LLM gateways, which are kind of like firewalls for AI, inspecting everything that goes in and out to block threats.
A huge part of building trustworthy AI is fighting this black box problem head-on. If we can't look inside a model or understand its training data, we can't really trust its outputs, especially for something that's critical. To tackle this, the Linux Foundation's AI and Data Foundation created something called the Model Openness Framework, or MOF. The whole point of the MOF is to create a clear, standard way to measure and talk about how open an AI model really is. It gets rid of the simple open or closed debate. Instead, it defines specific levels of transparency that let developers share their work in a way that promotes reproducibility, allows for auditing, and ultimately builds community trust.
The Model Openness Framework gives us this standardized ladder of transparency with 3 clear levels. Class 3, called Open Model, is the baseline. At this level, the creators release the model's architecture, its final trained weights, and a bunch of documentation describing its performance. This lets other people use the model and understand what it can do. Class 2, or Open Tooling, goes a big step further. It includes everything from Class 3, but also adds the actual code used for training and testing, plus the data used for evaluation. This is huge because it lets other people independently verify the creator's results. And finally, Class 1, Open Science, is the gold standard. It includes everything from the other 2 levels, but also releases the full, raw training data and all the code used to process it. This lets the entire community replicate the work from scratch, audit the data for bias, and truly build on the work in a totally transparent way.
And what's really fantastic to see is that the Nephio project is not running away from this responsibility. The community has publicly committed to embracing these open principles by aligning with the Model Openness Framework. Their stated goal is to start by hitting at least Class 3 compliance for any Gen AI models they develop. That is a really significant commitment. It means they're planning to release model parameters under open, permissive licenses. It means making sure all the supporting code is also open source. And it means a commitment to reporting detailed metrics on how the model was evaluated. This public pledge to transparency is absolutely vital for building the kind of broad community trust that a project like this needs to succeed.
Wow, we have covered a ton of ground on this journey. We started with the immense challenges of a new networking reality. 5G, the edge, the cloud. We unpacked Nephio as this new declarative foundation. We saw how generative AI is a powerful catalyst for that foundation. We explored real-world applications and the vital importance of the open-source ecosystem and the critical security guardrails. So now let's pull it all together and look toward the horizon. This final call to action from the white paper just sums up the whole spirit of this thing perfectly. This isn't about one company building a proprietary product to try and own a market. It's a humble and clear-eyed acknowledgement that the challenges facing the telecom industry are just too big and the opportunities are too great for any one group to solve alone. The future of intelligent network automation won't be built on a silo. It has to be built through a broad, collaborative, open-source effort. It needs the deep, real-world expertise of the telecom operators, the innovation of vendors and AI startups, and the passion of technologists from all over the industry. This is an open invitation to come together, to collaborate, and to build that smarter, more adaptable world, not through some magic wand, but practically, patiently, and persistently, one network at a time. And so we end with this final forward-looking question, because maybe the ultimate promise of this whole revolution isn't just about operational efficiency. It's not just about saving that 80% of an engineer's time. The real promise lies in what happens next, in what we choose to do with all that reclaimed human potential. When the most brilliant and creative minds in networking are finally freed from the mundane, repetitive work of manual configs and troubleshooting, what new frontiers will they conquer? What new kinds of services, things we can barely even imagine today, will they invent? What breakthroughs in resilience, security, and sustainability will they achieve? As we hand the keys for routine operations over to these intelligent systems, we are not making human engineers obsolete. We are liberating them. We are freeing them to become what they were always meant to be: the architects, the innovators, and the visionaries of a truly intelligent and connected future. The automation we've talked about today is the foundation, but the world that human creativity will build on top of it, that's the real destination. Thank you for joining this deep dive.